Hi, my name is Christopher Jones. I'm a product manager in the Oracle Database Networking, Data Access and Database Driver Group. In this video, I'm going to show you features that will supercharge your use of Python for data analysis and AI. Python is the language for these workloads. Popular Python packages use DataFrames or tensors for numerical analysis, AI, and data storage. Some of these packages are Pandas, Polars, Apache Arrow, TensorFlow, PyTorch, Dask, NumPy, Parquet, Delta Lake, and there are others. The extremely popular python-oracledb driver for Oracle Database now has fast methods for fetching data frames. I'll demonstrate examples in a minute. You can use these data frames in your chosen analysis or AI library or for writing to storage. The new query methods remove overheads that your previous extraction code has. You can also insert data frames directly and efficiently into Oracle Database. Your analytic and AI workflows now have fast, immediate access to data, whether you process it inside the database or in Python. Why would you use the new Python OracleDB driver methods? Because they are faster and more efficient. Here are quotes users have posted on our GitHub repository. You can see the significant benefits that Python OracleDB brings, and the larger the data, the bigger the benefit. The first code sample I want to show is the old method of using Pandas, which you might currently have. It is now the anti-pattern. The code starts by using SQL Alchemy to create a connection to the database. Note the array size parameter used to tune internal buffer sizes for optimal query fetching. It is set at the connection level, so it affects all select statements. Then the Pandas read SQL query method is called, which itself uses traditional query code paths in the Python OracleDB driver to ultimately do the select. Once the data frame has been fetched, Pandas operations can be performed. Here the code simply sums the salaries for each department. Let's run it. But look at the new way to get a data frame. This uses Python OracleDB's fetchDFAll method to directly get all the rows. Value 80 is bound to the where clause as before. Here you can set the array size to tune the internal buffer sizes for each query, which is an advantage. But the bigger efficiency is because the method fetches directly into a data frame format. PyArrow or your analytic package functionality is then used to do a zero-copy conversion to the data frame of whatever analytic package you are using. Here it is to Pandas. As in the previous example, once you have a data frame, you can do operations on it. In both these examples, it seems obvious that the group by could have been done in the SQL query itself. Of course, all of these packages offer sophisticated functionality. It is true that a lot of functionality could be done with SQL analytic queries, but there are legitimate reasons to extract the data into Python. You may want to do quick ad hoc testing with data frames, or you might need to interact with Python libraries that only use data frames. Your data frame skills might be better than your SQL skills, or perhaps your application needs to be portable across data sources, or you may even need to offload processing from the database host. Conversion to data frames or tensors for other Python packages that support the PyCapsule interface is similar. Here are examples of some of them. This is a small benchmark comparing the old Pandas method of querying a number column versus using the new fetchDFAll method for various numbers of rows. You can see the new method wins for performance, memory, and client CPU usage. There were similar results for other column data types. Of course, in your environment, results will differ from mine. My next code example shows how to iterate over a dataset using fetchdf batches. This example writes to the Delta Lake format, which is a file format based on Apache Parquet. When fetching, you can tune the batch size to optimize performance and memory usage. The code then reads back the data to check that it was written. You can also directly insert data frames into Oracle Database. This example first creates a table with a key and a value column. Then it creates a Pandas data frame independently of Oracle. This data frame can be bound directly to an insert statement with the execute many method. This method uses Oracle's efficient ArrayDML feature to do a batch insert. It also benefits from being able to read the data frame format directly. For many data types, this bypasses the need to convert to intermediary Python types. A quick benchmark shows inserting a Pandas data frame into a table with a number column. It compares the old Pandas method of inserting data versus the new way of binding directly with execute many. As the number of rows in the data frame increased, the new driver clearly won. We're moving the same data with far less client workload and with better throughput. The difference will vary with the data type and of course differ in your environment, but in general there is a win with reduced client CPU usage. I hope you've enjoyed this video. In the description you can find useful links and references. Python-oracledb and Oracle Database make using data frames and tensors significantly better. You can choose to run your workloads in Python or using Oracle Database's great inbuilt analytic and AI functionality. Look out for my next video where I focus on using Oracle Database 23AI's vector data type with data frames.